Hello everyone. In this today's video we'll learn about the length of the conductor and resistance. How the resistance is affected by changing the length of the conductor. Okay, if we change the length of the any conductor, how it varies with the resistance. Okay, let's understand. Okay, collect some iron spokes at different length with same cross section areas. Make a circuit. Connect one of the iron spokes at 10 centimeter length between P and Q. Measure the value of the current using the ammeter connected in the circuit and note the value in your notebook. Repeat this for other lengths of the iron spoke. So what actually it meant is what he's telling is what is given in the text is he's asking us to make a circuit diagram. Okay, we'll make first a circuit diagram. Okay, we'll make a circuit diagram. Okay, what I'm doing here is I'm taking a iron spoke, say 10 centimeter, means a small wire I'm taking. Okay, a small this is a wire, okay, of length 10 centimeter. I'm placing this 10 centimeter wire, okay, in between the ends of this conductor, okay, or we can take 1 centimeter, 10 centimeter, whatever we want. You, as it is the length of the conductor, we'll try to vary the length of the conductor, and we'll know how the value of the resistance will differ. Okay, first what I will do, I'll take 1 meter, 30 meter, or 100 meter, or I will take some 10 meter. Ten centimeter, 20 centimeter, and 30 centimeter. Okay, I'll take 10 centimeter, 30 centimeter. Okay, so I'm playing in the same way as we did in earlier video. That is, I'll take a plus terminal and a negative terminal. Okay, battery I'm connecting here, plus terminal and the minus terminal. We know that current travels from positive terminal to the negative terminal. Okay, positive terminal to the negative. This is a switch, that is a key, positive terminal and the negative terminal. What I am doing, I'm placing here the 10 centimeter iron wire. Okay, iron wire. I am soon after placing the iron wire, and I'll start the I'll switch on the key. Switch on the key. What happens if I'll switch on the key? The current starts flowing. So if the current starts flowing, what here the ammeter is there. Ammeter will give the reading how much current is flowing in this particular wire, iron wire, and the voltmeter will show what is the potential difference between the ends of this particular iron wire. So again the current will go to the negative terminal and comes to the positive terminal, and the path will continue. So what's happening here, I'm placing here the 10 centimeter wire. So here the voltmeter and the ammeter, that is the current, it will give some resistance value, means voltmeter will give some potential difference value, and the ammeter will give current value. Okay, current value. Suppose the resistance of this means V by I. Resistance means V by I. What's happening? 2 ohms it will give. I'll vary the length of this particular wire as 20 centimeters. Again I'll vary the length of this wire as 30 centimeters. Means if I am going on increasing the length of the wire, the value of the resistance will go on increasing. Means it will go on changing. If I'll decrease the length of the wire, the value of the resistance will be decreasing. Now suppose we'll understand here. This is suppose a wire. Okay, suppose I'll take a long wire, again and still more long wire. What is happening here? The distance covered in this, the distance covered to flow the current is less here. Okay, and the current flowing in this wire is more, and the current flowing in this wire is, means the length covered to travel the electrons in this more. What is happening? If the current, we know the inversely, if the current is more, resistance is less. Okay, current, if it is the current flowing is means resistance is less. What is happening here? The length of the wire, the length here is the, suppose 1 meter, 2 meters and 3 meters, means the current has to travel 1 meter long, and the current has to travel 2 meter long, and the current has to travel 3 meter long. Okay, means here the current, the distance, means the length covered by the length covered to flow the electrons is less than compared to this one. Means what is happening here? As we are increasing the length of this particular wire, the passage of the current is more. If the passage of the current is more, what is happening? The resistance will be more, because the wires, it gets heated up. The wires will get heated up, and the passage of the current, it has to be more. Means the length of the wire is more, the resistance of the wire is more. Okay, means it is directly proportional. If the resistance is more, the resistance will be more if the length of the wire is more. If the length of the wire is less, the resistance will be less. Means it is directly proportional. It is a directly proportional, but the condition is at constant temperature and cross sectional area should be same. Means the temperature should be constant and the cross sectional area should be same. Okay, so does the thickness of the current influence its resistance? Let us find out. Okay, means what does it mean is, here the wires we are changing here the length of the wires, 10 centimeter, 20 centimeter, 30 centimeter. Means here the resistance is going on changing here. The resistance is going on changing. So if we change here, if I place the 20 centimeter here, so the potential difference, that is voltage and the current will be differ. If the current will differ, the resistance will be differ. Okay, if I place 30 centimeter, again the current will be differing. Okay, so what is happening? If we go on changing the value of the length of the wire, the resistance will also change. Okay, the next one, does the thickness of the conductor affect the resistor? Yes, how it affects we'll see. Okay, suppose thickness means nothing but the area of a cross section. Okay, suppose I am taking the wire up to here, the length of the wire should be same. Here the length of the wire should be same. Suppose what I am doing, I am taking the 1 meter and 1 meter, but the thickness I am changing. Means area of cross section is different. Here the thickness is something different and different. 3 of different area of cross section. The same way here, what I have done here is, I will place here 1 meter wire of area of cross section. 1 meter means here the cross section will differ. I am placing this first wire I am placing here. So what happens if I place the first wire? It will show some voltage reading, it will show some ammeter reading. Wait, ammeter. These 3 wires, same length. These are of a same length, but the area of cross section is differing. Okay, area of cross section here it is differing. Suppose I will take the V, I will take here R, and I will take here the resistance. Okay, I will take R resistance. So what will happen here? This particular wire of area of some cross section I will place here. If I place here, what's happening? If I place here, the voltmeter will give some reading and the ammeter will give some reading, current. Again resistance, I will get some value. So if I place the next wire of area of cross section, something different from first one, and the third wire I am placing in this same circuit, and if I go on changing the wires of different cross sectional area, what will happen? I'll get the resistance. Suppose if I'll get the resistance here 2 ohms and 1 ohm and 0.5 ohm. Okay, the values will differ here. Resistance. The value of the resistance will differ in first case, in second case, and the third case, because we are changing here the area of cross section. As we are changing the area of cross section, voltage, current, voltage and current. We'll get the values, and the value of resistance we can see here in the voltmeter. With the help of the voltmeter we can get the value of voltage. Current, we'll get the value with the help of the ammeter. Value resistance I will get. So what we have noticed here, if I take the less cross section, the resistance is more. If I'll take the length of the wire with more area of cross section, the resistance is more. Okay, suppose if I'll take a wire of thin cross section, area of cross section, what is happen? It will be difficult for the current to flow from this. It will be difficult for it to flow. Okay, if I'll take a wire of more area of cross section, means the area of the thickness of the wire is more. Okay, if I suppose, see, if I take here, if I take this area of cross section and this area of cross section, in which area of in which wire the current will flow easily? Will the current will flow easily from this wire or from this wire? The current will flow easily from this wire rather than this wire, because the area of cross section this wire is less compared to that of the area of cross section. The area of cross section of this particular wire is more, the area of cross section in this wire is less. So the current will flow easily from this wire rather than in this wire. So in our house wirings we use this wire or this wire, because the power consumption, that is the power consumption is 240 volts. We usually use for fans and for small electrical appliances we'll use small thin area of cross section wires, because we don't need much flow of current. Okay, but I think you might have observed the wirings in poles. Okay, electrical poles, they'll use some thick wires, because the power supplies from the power station, it has to be transformed to our house. All over the streets or wherever the power supply is there should be power. The distribution of the power supply should be all over. So what happened there, the power supply should be in all around our particular area. So what happened there, the wires will be the area of cross section will be more. Okay, that is the difference. Means if the area of cross section is more, the resistance will be less. Means the current will flow easily. Okay, if the resistance is less, the current flow will easily. Means the resistance will be less for this and more from this. Means the current will flow easily from this, the current obstructs more in this. Okay, that is the concept here. So we'll see from the textbook. We'll read out the textbook for better understanding. Okay, so collect the iron rods of equal length. Okay, equal length but different area of cross section. Means length should be same, but the cross section should be differ. Connect one ends of the rods between point P and Q. Here P and Q. Here same way P and Q. Here P and Q. Note the value of the current using the ammeter connected to the circuit, and note, repeat this with the rods. Means repeat this with the other rods. Means different rods we have used of different area of cross section. The same thing history. Repeat this with other rods. Means one rod I have placed here. I have noted the value of voltmeter and ammeter. I got the resistance value this much. Now I am taking out this particular rod and I am using the other wire of some different area of cross section from that of first one. Okay, note the corresponding values of current in each case. Means as we are changing this one area of cross section of this particular one, in each case we have to write down the value of current and note them in your notebook. You will notice that the current flowing through the rod increases with increase in area of cross section. Means current flowing through the rod increases with increasing the area of cross section. The same thing. Means here we are increasing the area of cross section, the current will flow more. Here the area of cross section is less, the current will flow less. Okay, hence the resistance of the rod decreases with increase the area of cross section of the. Hence the resistance of a rod decreases with increase in the cross sectional area of the rod. Means here what is happening here? If the area of cross section is more, what is happening here? Here the area of cross section is more. Area of cross section is more means what? Resistance is low, current is more. Okay, the same thing. Resistance of the rod decreases, means resistance is decreasing here because easily it can flow the current. As the area of cross section is more, the current will flow easily. As the current is flowing easily, resistance is less, current is more, with increasing in the area of cross section of the. From this activity, we can conclude that the resistance of the conductor is inversely proportional to the area of cross section. Means inversely proportional. As the area of cross section increasing, what is happening? Resistance is decreasing. Okay, area of cross section increasing. Here we have increased the area of cross section. As we are increasing the area of cross section, what is happening? Resistance is decreasing. As the resistance is increasing, what is happening? Current will increase. Okay. At constant temperature and length of the conductor. Here the condition is, what? In above condition, the temperature should be constant and the area of cross section should be constant here. Okay. At constant temperature and cross section area, temperature and cross sectional area should be constant. But in this case, what is telling, what is given in text is a constant temperature. In both the temperature should be constant, but here the length of the conductor should be constant. Means we should not change the length of the conductor. We can change the area of cross section, but the length of the conductor should not be changed. It should be constant. In this activity, the cross sectional area should not be changed. The length of the conductor may vary. Because we are performing the experiment only because of length of the conductor. Okay. We want to know how the resistance will be affected while we are changing the length of the conductor. While we will change the length of the particular conductor, how it's being affected. Okay. Thank you everyone. Let's in next video we will see the how this resistivity, okay, about the resistivity we'll see next video. Thank you everyone.